Hello everyone, welcome to today's lecture. So in today's class we will start with the NCERT section 2.3 inverse trigonometric functions theory portions, right? The images, text and other materials used in our presentations are for educational purposes only. We respect the intellectual property rights of the original creators and owners. If you are the owner and have any concerns or issues, please contact us at sathee@iitk.ac.in and we shall remove the content immediately. Please note that parts of the content may have been generated using generative AI, which is experimental. Okay, so let us start with the theory portion. If you have any doubt while I'll teaching, you can ask in the comment section, right? So outline what we will study in today's lecture is we will start with the NCERT section 2.3, that is properties of inverse trigonometric functions. We will discuss NCERT example 3, 4 and 5, right? So let us start with the properties of inverse trigonometric functions with property 1. Property 1 says sine of sine inverse x is equal to x for all x belongs to -1 to 1, right? Sine of sine inverse x is equal to x for all x belongs to -1 to 1. So let us start with the proof. Let y is equal to sine inverse x, right? Let y is equal to sine inverse x. So by definition, sine y is equal to x, right? And sine y is equal to x and y belongs to minus. Sine y is equal to x and y belongs to minus pi by 2 to pi by 2, right? Clear? Y belongs to minus pi by 2 to pi by 2. Therefore, we can say that sine of sine inverse x is equal to x, right? Sine of sine inverse x is equal to x, right? For all x belongs to -1 to 1, right? Sine of sine inverse x is equal to x because y is equal to sine inverse x, right? We know that y is equal to sine inverse x, right? Okay. Similarly, using the same concept, following results can be obtained. Cos of cos inverse x is equal to x for all x belongs to -1 to 1. Clear? Tan of tan inverse x is equal to x for all x belongs to real. Cot of cot inverse x is equal to x for all x belongs to real, right? Sec of sec inverse x is equal to x for all mod x greater than equal to 1, right? That is for all x greater than equal to 1 to infinity and for x less than equal to minus infinity to -1, right? Cosec of cosec inverse x is equal to x for all mod x greater than equal to 1. Clear? So all these properties you have to remember. Also you have to remember this property is works in which domain, right? These classes will run till we complete all the sections of NCERT, right? Of class 12. Got it? And parallelly class 11th classes is also going on, right? So let us move with the property 2. Property 2 says sine inverse sine x is equal to x. Sine inverse sine x is equal to x for all x belongs to minus pi by 2 to pi by 2. So let us prove this property also. So let x be any real number in minus pi by 2 to pi by 2, right? Let x be any real number in minus pi by 2 to pi by 2, right? So the value of sine x lies in -1 to 1, and in this interval, the inverse sine function returns the original value. Clear? Returns the original angle lying in the interval minus pi by 2 to pi by 2. Got it? So the value of sine x lies in -1 to 1 and in this interval, the inverse sine function returns the original angle, right, lying in minus pi by 2 to pi by 2. Got it? Therefore, we can say that the sine inverse of sine x is equal to x for all x belongs to minus pi by 2 to pi by 2, right? Sine inverse of sine x is equal to x for all x belongs to minus pi by 2 to pi by 2. Okay. Similarly, using the same concept, following results can be obtained, right? These results we can obtain by using the same concept. The following results you can remember: cos inverse cos x is equal to x for all x belongs to 0 to pi. Tan inverse tan x is equal to x for all x belongs to minus pi by 2 to pi by 2, right? Cot inverse cot x is equal to x for all x belongs to 0 to pi, right? And sec inverse sec x is equal to x for all x belongs to 0 to pi, right? And x not equal to pi by 2. Clear? X should not be equal to pi by 2 here. You have to take care of that, right? Cosec inverse cosec x is equal to x for all x belongs to minus pi by 2 to pi by 2, right? Cosec inverse cosec x is equal to x for all x belongs to minus pi by 2 to pi by 2, and x does not equal to 0. X is not equal to 0, right? You can note that these properties hold true because they are derived from the fundamental definitions and the principal value interval, that is principal branches of the trigonometric and the inverse principal value or principal branches of the trigonometric and the inverse trigonometric functions. Got it? Right. Okay, let us move to the next section. Property 3. Right, let us discuss property 3. Property 3 says sine inverse minus x is equal to minus of sine inverse x, right? When x belongs to minus 1 to 1. That is, suppose like sine inverse suppose 0.5 will be equal to sine inverse minus of 0.5 will be equal to minus of sine inverse 0.5. Got it? And see, the value you will take here will always lie between minus 1 to 1. Clear? Will always lie between minus 1 to 1. This thing you have to keep in mind, right? Let us prove this. Proof. Let sine inverse minus x is equal to y, right? Let us assume sine inverse minus x is equal to y. So y belongs to minus pi by 2 to pi by 2, right? Y belongs to minus pi by 2 to pi by 2. So by definition, we can say that the minus x will be equal to sine y, right? Minus x is equal to sine y. This implies x is equal to minus of sine y, right? If minus x has come out to be sine y, then we can say that the x is equal to minus of sine y, right? Thus we can say that the x is equal to sine of minus y, right? X is equal to sine of minus y, right? Therefore minus y belongs to minus pi by 2 to pi by 2, right? Minus y, because minus y belongs to minus pi by 2 to pi by 2. Got it? See, if y belongs to minus pi by 2 to pi by 2, see, y belongs to minus pi by 2 to pi by 2, then minus y will belongs to minus pi by 2 to pi by 2, right? Clear? So we can say that the sine inverse x will be equal to minus of y, and it is equal to minus of sine inverse minus x, right? Sine inverse x is equal to minus of sine inverse minus x, right? Therefore, we can say that the sine inverse minus x is equal to minus of sine inverse x, right? Sine inverse of minus x will be equal to minus of sine inverse x, right? Similarly, using the same concept, following results can be obtained. You can write, you can like remember following results also. So cosec inverse minus x will be equal to minus of cosec inverse x for all mod x greater than equal to 1, right? For all mod x greater than equal to 1, right? Also, tan inverse minus x will be equal to minus of tan inverse x when x belongs to real. Clear? Let us move to the next property, property 4. Property 4 is basically cos inverse minus x is equal to pi minus cos inverse x, right? You will remember this. See, sine inverse minus x is equal to minus of sine inverse x, right? Minus of sine inverse x. But cos inverse minus x is not equal to minus of cos inverse x, right? Clear? It is equal to like pi minus cos inverse x, right? It is equal to pi minus cos inverse x. Cos inverse minus x is equal to pi minus cos inverse x, right? This thing you have to keep in mind, right? And see, x will belongs to minus 1 to 1 always, right? X will belongs to minus 1 to 1. Next, let us prove this. Let cos inverse minus x is equal to y. So y belongs to 0 to pi, right? Y belongs to 0 to pi. So by definition, we can say that minus of x will be equal to cos y, right? Minus of x will be equal to cos y. So x can be written as minus of cos y, right? And now we know that like cos of pi minus theta is equal to minus of cos theta, right? Cos of pi minus theta is equal to minus of cos theta. So in place of minus cos y, we can write cos of pi minus y, right? In place of minus of cos y, we can write cos pi minus y, right? And pi minus y will belongs to 0 to pi, right? Pi minus y will belongs to 0 to pi, isn't it? Thus we can say that cos inverse x will be equal to pi minus y, right? Therefore, cos inverse x will be equal to pi minus cos inverse minus x, right? So we have proved this. Cos inverse x is equal to pi minus cos inverse minus x. Got it? Right. Cos inverse x will be equal to pi minus cos inverse minus x, right? Similarly, using the same concept, the following results can be obtained. See, sec inverse of minus x is equal to pi minus sec inverse x, right? Cot inverse minus x will also be written as pi minus cot inverse x, right? So these properties you have to remember always, right? Okay, let us move to the next property, property 5. So what property 5 says? Sine inverse x is equal to cos inverse 1 by x, right? Sine inverse x is equal to cos inverse 1, sine inverse x is equal to cosec inverse 1 by x, right? Sine inverse x is equal to cosec inverse 1 by x, and x belongs to minus 1 to 1 except 0, right? Why except 0? Because like cosec when x is equal to 0, cosec inverse 1 by, see, 1 by, it is 1 by x. When you will put x is 0, this will not be defined, right? Because 0 in the denominator is not defined basically, right? So x will belongs to minus 1 to 1 except 0, right? So let us prove this. So let us assume sine inverse x equal to theta, right? Sine inverse x equal to theta. So by definition, we can say that sine theta will be equal to x, right? And theta will belongs to minus pi by 2 to pi by 2, right? And theta will not be equal to 0, right? Theta will not be equal to 0 if x is not equal to 0, right? If x is not equal to 0, that means theta will not be equal to 0. Clear? So we know that cosec theta is equal to 1 by sine theta, right? We know that cosec theta is equal to 1 by sine theta, and we have assumed sine theta is x. So cosec theta will be equal to 1 by x, right? So for this case, theta will be equal to cosec inverse 1 by x will be equal to theta, right? Cosec inverse 1 by x will be equal to theta. Because the principal value branch of cosec inverse is theta which belongs to minus pi by 2 to pi by 2, right? And theta should not be equal to 0. Therefore, we can say that sine inverse x will be equal to cosec inverse 1 by x, right? Sine inverse x will be equal to cosec inverse 1 by x for all x belongs to minus 1 to 1, and x should not be equal to 0, right? For all x belongs to minus 1 to 1, and x should not be equal to 0. So you have to remember this property, right? So similarly, using the same concept, following results can be obtained. You can like remember cos inverse x is equal to sec inverse 1 by x when x belongs to minus 1 to 1 except 0, right? Again, why except 0? Because we have taken 1 by x, right? Clear? Because we have taken 1 by x, and like in 1 by x, when we will put x equal to 0, then like denominator will be 0, right? And we know that denominator cannot be equal to 0, right? And see, tan inverse x is equal to cot inverse 1 by x, right? We know that tan inverse x is equal to cot inverse 1 by x if x is greater than 0, or cot inverse 1 by x minus pi if x is less than 0, right? See, tan inverse x will be equal to cot inverse 1 by x if x is greater than 0, right? And if x is less than 0, that means we will write cot inverse 1 by x minus pi, right? Tan inverse x is equal to cot inverse 1 by x minus pi if x is less than 0, right? That is, suppose tan inverse 5 will be equal to cot inverse 1 by 5. Got it? But tan inverse or minus 5 will be equal to cot inverse 1 by cot inverse 1 by 5 minus pi, right? Cot inverse 1 by 5 minus pi. You can write this. Okay. Next, also you can write cot inverse x equal to 1 by tan inverse x if x is greater than 0, and cot inverse x you can write it as tan inverse 1 by x plus pi if x is less than 0, right? Tan inverse 1 by x plus pi if x is less than 0. Clear? Therefore, you always have to take care about the domain while writing the inverse trigonometric functions, right? Because like all the stories of inverse trigonometric functions is based on the restriction of domains, right? So like while writing any expression, you must take care of the domain at that point, right? Okay, is it clear till here? Okay, let us move to the next property. Property 6. See, this property is very important. Sin inverse x plus cos inverse x is equal to pi by 2 for all x belongs to minus 1 to 1, right? Sin inverse x plus cos inverse x will be equal to pi by 2 for all x belongs to minus 1 to 1, right? So let us prove this. So let us assume sin inverse x is equal to y, right? So y belongs to minus pi by 2 to pi by 2, right? Y belongs to minus pi by 2 to pi by 2. Got it? So we have assumed sine inverse x equal to y. Therefore, x will be equal to sine y, right? X is equal to sine y. So you can write sine y as cos of pi by 2 minus y, right? So pi by 2 minus y will belongs to 0 to pi, right? X equal to sine y, and it is equal to cos of pi by 2 minus y, and pi by 2 minus y will belongs to 0 to pi, right? So this imply cos inverse x is equal to pi by 2 minus y, right? And what we have assumed y as sine inverse x. So cos inverse x can be written as pi by 2 minus sine inverse x, right? Cos inverse x can be written as pi by 2 minus sine inverse x. Therefore, sine inverse x plus cos inverse x will be equal to pi by 2, right? Therefore, sine inverse x plus cos inverse x will be equal to pi by 2. Similarly, using the same concept, we can also remember the following result. You can remember like tan inverse x plus cot inverse x equal to pi by 2 when x belongs to real, and cosec inverse x plus sec inverse x is equal to pi by 2 when mod x greater than equal to 1, right? Cosec inverse x plus sec inverse x is equal to pi by 2, right? When mod x greater than equal to 1. Clear? See, you can just like memorize memorize all the like formulas. You can see the proof also, right? Prove also how this formula has come, but you just have to memorize the final formula, right? The final formula which has come after proving proving the result, the final formula you will have to memorize itself, right? Let us move to the next property. Property 7. Property 7 says if x and y greater than 0, if x and y greater than 0, then tan inverse x plus tan inverse y will be equal to tan inverse x plus y upon 1 minus xy, right? When xy is less than 1, and tan inverse x plus tan inverse y will be equal to pi plus tan inverse x plus y upon 1 minus xy when xy greater than 1, right? Clear? When x into y greater than 1, it will be equal to pi plus tan inverse x plus y upon 1 minus xy, and when it is xy less than 1, then it will be equal to tan inverse x plus y upon 1 minus xy, right? Isn't it? Let us prove this result also. So let us assume tan inverse x is equal to alpha, right? Let us assume tan inverse x is equal to alpha and tan inverse y is equal to beta, right? We have assumed tan inverse x is equal to alpha and tan inverse y is equal to beta, where xy is greater than 0, right? X and y is greater than 0. That is, x is equal to tan alpha and y is equal to tan beta, right? X is equal to tan alpha and y is equal to tan beta, and alpha beta will belongs to 0 to pi by 2, right? Alpha beta belongs to 0 to pi by 2. Got it? Now use some additional formula also of tan. That is like you know that tan alpha plus beta is equal to tan alpha plus tan beta upon 1 minus tan alpha tan beta, right? Therefore, we can write it as tan alpha is equal to x here. So we will write it as x plus y upon 1 minus xy, right? And alpha beta will belongs to 0 to pi, right? Alpha plus beta will belongs to 0 to pi here. See, analyze the sign of denominator, which is 1 minus xy, right? Which is 1 minus xy. When case one is when x like 1 minus xy is greater than 0, that is xy less than 1, right? When 1 minus xy is greater than 0, that is xy is less than 1, then we can write like 1 minus xy is greater than 0, that is x plus y upon, and x and y are greater than 0, so x plus y will be greater than 0 also, right? So we can say that x plus y upon 1 minus xy overall will be greater than 0, right? X plus y upon 1 minus xy will overall will be greater than 0, right? Therefore, we can say that tan of alpha plus beta will be greater than 0, where alpha plus beta will belongs to 0 to pi, right? This implies alpha plus beta will belongs to 0 to pi by 2. So since tan alpha plus y 0 to pi by 2, it will belong, because tan alpha plus beta is equal to x plus y upon 1 minus xy, and alpha plus beta will belongs to 0 to pi by 2, right? Alpha plus beta is belonging to 0 to pi by 2. Why? Because x plus y upon 1 minus xy is basically greater than 0, right? So in first quadrant, tan theta is positive. Therefore, we can say that alpha plus beta is lying between 0 to pi by 2, right? Now we can write alpha plus beta is equal to tan inverse x plus y upon 1 minus xy, right? Alpha plus beta is equal to tan inverse x plus y upon 1 minus xy. Therefore, tan inverse x plus tan inverse y will be equal to tan inverse x. Alpha is equal to tan inverse x and beta is equal to tan inverse y, right? Alpha is equal to tan inverse x and beta is equal to tan inverse y, we know. Therefore, it will be tan inverse x plus tan inverse y will be equal to tan inverse x plus y upon 1 minus xy, where xy is less than 0. That we have assumed, taken here, right? Because 1 minus xy is greater than 0. Clear? So we can say that tan inverse x plus tan inverse y will be equal to tan inverse x plus y upon 1 minus xy, where xy is less than 1. Right? So let us take case 2. Case 2 is when 1 minus xy is less than 0. Right? 1 minus xy is less than 0, that is xy is greater than 1. Clear? If we have taken 1 minus xy less than 0, that is xy greater than 1. So if like x plus y upon 1 minus xy less than 0, right? Less than 0, because see x plus y will be greater than 0 always, because x is greater than 0 and y is greater than 0. Now we have assumed that 1 minus xy is less than 0. Therefore, see, x plus y upon 1 minus xy will be less than 0 always, right? Because denominator is less than 0, numerator is greater than 0 always. Clear? Therefore, we can say that x plus y upon 1 minus xy will be less than 0. This implies, see, tan alpha plus beta is less than 0, where alpha plus beta will belongs to 0 to pi, right? T, alpha plus beta is less than 0. We know that in first quadrant, that is 0 to pi by 2, tan theta is positive, and in second quadrant, that is pi by 2 to pi, tan theta is negative, and we are getting tan alpha plus beta is less than 0. Therefore, we can say that alpha plus beta will belongs to pi by 2 to pi, right? Alpha plus beta will belongs to pi by 2 to pi. Clear? Because tan alpha plus beta is coming out to be negative, right? But the range of tan inverse function is basically minus pi by 2 to pi by 2. Clear? Range of tan inverse function is basically minus pi by 2 to pi by 2. Now, since tan of alpha plus beta is equal to tan of alpha plus beta minus pi, and alpha plus beta minus pi will belongs to minus pi by 2 to 0, right? Tan of alpha plus beta will be equal to tan of alpha plus beta minus pi. Why we have written tan of alpha plus beta minus pi? Because like tan theta is coming out to be negative. See, what can we write? Tan of like pi minus alpha plus beta. Alpha plus beta. It will be second quadrant, so we can write it as minus of tan alpha plus beta, right? Therefore, we have taken alpha plus beta. That is C. Tan of alpha plus beta minus pi is basically like minus of tan pi minus alpha plus beta, right? Clear? And tan of pi minus alpha plus beta is basically minus of alpha plus beta. So minus of minus alpha plus beta, minus of minus tan alpha plus beta, right? We will get tan of alpha plus beta, isn't it? That's why we have taken tan alpha plus beta is equal to tan of alpha plus beta minus pi, right? If anyone do not understand, you can ask, right? Okay. Therefore, we can write like tan alpha plus beta is equal to tan alpha plus beta minus pi, right? And like see, if alpha plus beta belongs to pi by 2, therefore alpha plus beta minus pi will belongs to minus pi by 2 to 0, right? And we can write tan of alpha plus beta minus pi is equal to tan of alpha plus beta, right? Tan of alpha plus beta minus pi is equal to tan of alpha plus beta, which is equal to x plus y upon 1 minus xy, right? So we can say that alpha plus beta minus pi will be equal to tan inverse x plus y upon 1 minus xy, right? Alpha plus beta minus pi will be equal to tan inverse x plus y upon 1 minus xy. Therefore, alpha is basically, see, we will move this pi on this side. So right hand side will be pi plus tan inverse x plus y upon 1 minus xy. And alpha is tan inverse x and beta is tan inverse y, right? So alpha, so we can write finally tan inverse x plus tan inverse y is equal to pi plus tan inverse x plus y upon 1 minus xy, where xy is greater than 1, right? Where xy is greater than 1. Got it? So in this way, we have proved for both the cases when 1 minus xy is less than 0, that is xy is greater than 0, and another case we have already proved that when xy is less than 1, right? When xy is less than 1, then you can write tan inverse x plus tan inverse y is equal to tan inverse x plus y upon 1 minus xy. And when xy is greater than 1, you can write tan inverse x plus tan inverse y is equal to pi plus tan inverse x plus y upon 1 minus xy, right? Clear? Hope you understood. If anyone have doubt, please, if you can ask in the chat box. Okay. Okay, let us move to the next property. Property 8. See, property 7 we have taken when x and y was greater than 0. In this case, we have taken when x and y is less than 0. So what can we do if x and y is less than 0? See, tan inverse x plus tan inverse y is equal to tan inverse x plus y upon 1 minus xy when xy is less than 1. See, when xy less than 1, then it always will be equal to tan inverse x plus y upon 1 minus xy, whatever will be the value of x and y, right? Whatever will be the value of x and y, that is like both xy is positive, both xy is negative. For both the cases, when xy less than 0, tan inverse x plus tan inverse y will be equal to tan inverse x plus y upon 1 minus xy. But for this case, when xy is less than 0, the value of tan inverse x plus tan inverse y will be equal to minus pi, right? Minus pi plus tan inverse x plus y upon 1 minus xy when xy is greater than 1, right? So the problem arises when xy is greater than 1, right? So when xy is greater than 1, and x greater than 0 and y greater than 0, then we will write tan inverse x plus tan inverse y is equal to pi plus tan inverse x plus y upon 1 minus xy, right? And when xy greater than 1 and x less than 0 and y less than 0, then tan inverse x plus tan inverse y will be equal to minus pi plus tan inverse x plus y upon 1 minus xy, right? You have to remember this, right? These two cases. So let us prove this also. So we can prove this property by the similar process also. So similarly, using the same concept, following results can be obtained. Tan inverse x minus tan inverse y will be equal to tan inverse x minus y upon 1 plus xy when xy greater than minus 1, right? Xy greater than minus 1. Second, 2 tan inverse x is equal to tan inverse 2x upon 1 minus x square when mod x less than 0. How we got 2 tan inverse x? See, we have put x equal to y here, right? We have put x equal to y here. So when x is equal to y, then this will be equal to 2 tan inverse x, right? And this will be equal to tan inverse 2x upon 1 minus x square, right? Isn't it? So you can remember that 2 tan inverse x is equal to tan inverse 2x upon 1 minus x square. Clear? Okay. Hope you are getting. If you have any doubt, you can ask in the comment section. Okay, you can ask in the comment section. Okay, let us move. So let us see NCERT example 3. Example 3, question number 1 says, show that we have to show that sine inverse 2x root over 1 minus x square is equal to 2 sine inverse x when x is between minus 1 by root 2 to 1 by root 2. And question number 2 says sine inverse 2x root over 1 minus x square is equal to 2 cos inverse x when x is between 1 by root 2 to 1. Clear? So you have to show this, right? So if anyone can prove this, he can try. I'm giving you 1 minute to solve this. After that, I'll solve this question, right? So I'm giving the hint. How can you apply? How can you prove this? See, you can take sine inverse x as something y or theta, right? Sine inverse x as something y or theta. Clear? Then x will be equal to sine theta, right? If you take sine inverse x is equal to theta, then x will be equal to sine theta. Clear? X will be equal to sine theta. Then in the right hand side, you can put sine inverse 2 sine theta into 1 minus sine square theta, right? 1 minus sine square theta. So you'll get 2 sine theta into cos theta, right? 2 sine theta into cos theta. Always you have to take care about the domain also, right? You have to take care about the domain also, isn't it? Yeah, in first case it is 2 sine inverse x, and in second case it is 2 cos inverse x, right? Also see the domain also. When x is between minus 1 by root 2 to 1 by root 2, it is 2 sine inverse x, and when x is between 1 by root 2 to 1, it is 2 cos inverse x, right? So you have to take care of domain accordingly. Okay, in this way you can try to solve this question. I have given sufficient hint. You can try now. So what we can do here is, see, let us move to the solution part. How can we approach this type of question? See, as we have as I have given hint, you can let x is equal to tan theta, right? You can let x is equal to tan theta. Okay. Then sine inverse x will be equal to theta, right? Sine inverse x will be equal to theta. Now we have sine inverse in the left hand side. You can write sine inverse 2x into 1 minus x root over 1 minus x square is equal to sine inverse 2 into sine theta root over 1 minus sine square theta, right? Clear? And it will be equal to sine inverse 2 sine theta into cos theta, which will be equal to sine inverse sine 2 theta, and it is equal to 2 theta, right? Therefore it will be equal to, so it will be equal to 2 theta. So uh, this proves that sine inverse 2x root over 1 minus x square is equal to 2 sine inverse x, right? And see, second thing, second case, you can how you can prove, you can take x is equal to cos theta, right? X is equal to cos theta. Got it? When you will put x equal to cos theta, and by doing above process, you will get, see, after putting x equal to cos theta, in the left hand side you will get sine inverse 2 cos theta into sine theta again, right? Because 1 minus cos square theta is equal to sine theta. So you will get sine inverse sine 2 theta again, which is equal to 2 theta, right? Clear? Which is equal to 2 theta, and right, 2 theta, and 2 theta will belongs to 2 theta will belongs to what is 2 theta? We have taken theta as cos theta, right? So 2 theta will be cos inverse x. Clear? 2 cos inverse x, like that, right? Hope you understood this question. If you have any doubt, you can ask in the comment section. Okay, let us move to the next question. NCERT example 3, that was it. So let x equal to sine theta, then sine inverse x equal to theta, right? Then we have what we had, sine inverse 2x, right? That we had sine inverse 2x root over 1 minus x square is equal to sine inverse 2 sine theta into 1 minus sine square theta, right? And it is equal to sine inverse 2 sine theta into cos theta, right? Clear? And it will be equal to sine inverse sine 2 theta equal to 2 theta, right? So we got 2 sine inverse x, right? And similarly, by taking x equal to cos theta, as we have proved, therefore we got sine inverse 2x root over 1 minus x square is equal to 2 cos inverse x. Got it? Okay. So NCERT example 4, you have to express tan inverse cos x upon 1 minus sin x, tan inverse cos x upon 1 minus sin x, when x belongs to minus 3 pi by 2 to minus 3 pi by 2 to pi by 2 in the simplest form, right? You need to express tan inverse cos x upon 1 minus sin x when x belongs to minus 3 pi by 2 to pi by 2 in the simplest form, right? So how can you express this expression as simplest form? See, the hint of this question is, first you try to simplify the term inside this cos x upon 1 minus sin x, right? Try to simplify the cos x by upon 1 minus sin x. by taking some half angle formula, right? By taking some half angle formula, then you will be able to get this into the simplest form, right? Okay, so let us see. So we can write tan inverse of cos x upon 1 minus sin x as cos x can be written as cos of 2 into x by 2, right? Now we know that cos 2 theta is equal to cos square x by 2 minus sin square x by 2, right? Isn't it? Cos 2 theta is equal to cos square theta minus sin square theta. Therefore, we have written tan inverse of cos square x by 2 minus sin square x by 2 upon, in the numerator you can write, see, 1 you can write as cos square x by 2 plus sin square x by 2, it is equal to 1. And sin x can be written as sin x is equal to sine of 2 into x by 2, right? Which is equal to sin 2 theta. And we know that sin 2 theta is equal to 2 sin theta cos theta, right? 2 sin theta cos theta. And theta is x by 2. So you can write 2 sin x by 2 into cos x by 2. Yes, this is formula. Sin 2 theta is equal to 2 sin theta cos theta. It is formula which we have you might have learned in class 11, right? Also, cos 2 theta is equal to cos square theta minus sin square theta. Both are formula, right? So, see, now above expression is basically cos square x by 2 minus sin square x by 2, which is equal to like a square minus b square, which you can write tan inverse a square minus b square. You can write it as cos x by 2 plus sin x by 2 into cos x by 2 minus sin x by 2, right? Which is a plus b into a minus b. Upon, in the denominator, you can write cos x by 2 minus sin x by 2 whole square, right? Now you can see this term will cancel out eventually, right? So like minus terms cancel out. One minus in the numerator and one minus in the denominator will cancel out, and you are left with tan inverse cos x by 2 plus sin x by 2 upon cos x by 2 minus sin x by 2, right? So we can write tan inverse 1 plus tan x by 2 upon 1 minus tan x by 2, right? Tan inverse 1 plus tan x by 2 upon 1 minus tan x by 2. Therefore, you can write tan inverse tan pi by 4 plus x by 2, right? Because see, 1 plus tan x by 2 upon 1 minus tan x by 2. How can you write this as tan pi by 4 plus x by 2? See, we know that 1 is tan pi by 4, right? 1 is tan pi by 4 plus tan x by 2 upon 1 minus. So 1 is already multiplied 1 into tan x by 2. So you can write 1 as 1 tan pi by 4 into tan x by 2. Now see, this is for tan a plus tan b, right? So you can write this as tan pi by 4 plus x by 2, right? Tan pi by 4 plus x by 2, right? Therefore, you can write tan inverse 1 plus tan x by 2 upon 1 minus tan x by 2 as tan inverse tan of pi by 4 plus x by 2, which is equal to pi by 4 plus x by 2, right? Clear? So tan inverse tan of pi by 4 plus x by 2 will be equal to pi by 4 plus x by 2, right? Okay. Therefore, we have simplified the above expression as pi by 4 plus x by 2. So correct answer will be pi by 4 plus x by 2. Got it? Okay, let us move to the next question. Next question is write cot inverse 1 by root over x square minus 1 when x is greater than 1 in the simplest form. So what you didn't understand, please ask. See, when I stop, you need to ask there, right? We can't go we can't go in the previous slide, right? Okay. Try to focus on this example. Write cot inverse 1 by root x square minus 1 when x is greater than 1 in the simplest form, right? We have to write cot inverse 1 by root over x square minus 1 when x is greater than 1 in the simplest form. How can we write it in the simplest form? Try this, after that I will explain, right? First you try to solve this, after that I will explain. Okay, so let us solve this question. So let us move to the solution part. Let x is equal to sec theta, right? We have assumed let x is equal to sec theta. Then root over x square minus 1 will be equal to root over sec square theta minus 1, right? And we know that sec square theta minus tan square theta is equal to 1, right? Sec square theta minus tan square theta is equal to 1. So like sec square theta minus 1 is equal to tan square theta, right? Sec square theta minus 1 is equal to tan square theta. Therefore, we have written sec square theta minus 1 as tan square theta, and root over tan square theta is basically tan theta, right? Root over tan square theta is basically tan theta. Therefore, cot inverse 1 by root over x square minus 1 will be equal to cot inverse cot theta, right? And it is equal to theta. We know that cot inverse cot theta is equal to theta, right? And we have assumed x equal to sec theta, right? Then theta will be sec inverse x. Clear? Which is in the simplest form, right? So the simplest form of this expression is basically sec inverse x, right? Okay, you can see it once again. We have taken, so let's say x equal to sec theta, right? So what we have taken, root over x square minus 1 will be equal to root over sec square theta minus 1, right? Which is equal to tan theta. We know that sec square theta, root over sec square theta minus 1 is equal to tan theta, right? Therefore, cot inverse of 1 by root over x square minus 1 is equal to cot inverse of cot theta, which is equal to theta, right? And we have taken theta as sec inverse x, right? Clear? So we can say that this is the simplest form of the given expression, right? Okay. Now, if you have another doubt, you can ask. If you have any other doubt, you can ask now. Yes, you can use another things, but the expression will come out to should come out to be as simplest form, right? You cannot you cannot use anything like let us take x is equal to cos theta, right? Clear? If you will take x equal to cos theta, then it will not be simplified, right? So you can take any value of x in such a way that the equation comes out to be in the simplified form, right? Clear? So you have to put in such in such a way, otherwise it will be difficult to move in the simplified form, right? Yeah, it will be difficult to prove then. If you take anything x equal to any trigonometric ratio, right? You have to put that trigonometric ratio which will come out to be in simplified form. And we know that sec square theta minus 1 is tan square theta. So root over tan square theta will be equal to tan theta, right? Because see, also we have to convert this in terms of cot inverse cot theta, right? Cot inverse cot theta, then only we will get theta, right? If you will get suppose cot inverse sec theta, then you cannot write it as theta, right? Clear? Therefore, we have simplified in such a way that it becomes. See, these things will come out with the practice, right? These things will come out with the practice. When you will practice a lot of question, you will be able to see what should we put in place of x so that it will come out to be in the simplified form, right? Clear? So practice as much as you can, and you will be able to see which thing to take in substitution, right? Okay. Hope you understood. Thank you so much.